Aloha and welcome. In this video, we're going to be talking about redundancy. Particularly, we're going to talk about network redundancy and resilience. So there's a lot of common elements in the designs for redundancy and resilience, and one of those is geographical dispersal of systems. So when we're dispersing our systems here, we're going to make sure that any single disaster attack or failure of some sort won't bring down the systems that we're using here. So they recommend that a distance about 90 miles between systems is recommended. We also have the idea of the separation of servers and other devices within our data centers. We also talk about the use of multiple network paths known as multipath solutions. And then that's going to ensure that, like, if you have a severed cable or failed device, it's not going to cause a loss of connectivity. Then you've got redundant network devices. You can have multiple routers. You can have security devices like firewalls and IPSs or security appliances so that those don't become your single point of failure. You also need to protect your power supplies. So you can use UPSs, PDUs, things like that. You've also got to worry about things like failed disk servers and other devices that can cause an outage. You also have to, you've got to make sure that you use a diverse, amount of technology in a way that's not going to, it'll build resilience into your infrastructure. You're not always relying on the same technology, the same brand of equipment, things like that. So you want that diversity built in as well. So one thing we talk about is NIC teaming or NIC bonding. So this comes into our discussion of high availability for network resources around multipath or path diversity configurations. So when we're talking about path diversity or path diversification, we're talking about a multipath configuration that's going to allow us the most optimal path for data flow reliability. And we use NIC bonding or NIC teaming it's a configuration where we're going to be aggregating or bonding these physical devices into a single logical NIC so we can increase our bandwidth that way. So routers, they provide default gateway high availability by using a first hop redundancy protocol called FHRP. And FHRP, it's a protocol that's used to increase a default gateway's availability by aggregating multiple routers. So you're going to take multiple routers and you're going to aggregate those into a single virtual router. And there's two different types. One is open source. The other one is, or I say open source, it's non-proprietary. The other one is proprietary. So you've got virtual route redundancy protocol, VRRP. That is, it's a non-proprietary proprietary first hop redundancy protocol that's available for a lot of different routers. Then you've got the hot standby router protocol, the HSRP, and it's a Cisco proprietary FHRP type, and it's specifically for Cisco routers. And you'll learn more about this if you're ever studying for the Network Plus exam. So there's a discussion of whether NIC teaming is NIC bonding. They're essentially the same thing. It's just that NIC teaming gives you a little bit more in the way of features than just NIC bonding itself, which is, in general, the aggregation of multiple lines into a single, larger amount. We also, when we're talking about network redundancy, we have to talk about the power supply to those devices as well. So we talk about power supply units, PSUs. They're the hardware that converts and supplies received electrical power to other computing hardware. You've got the concept of dual PSUs, the power supply units, or dual supply. That's when you've got two different power supplies in a system so that one going down isn't going to bring the whole thing down. You've got the idea of a power distribution unit, and that's an electrical power strip that's able to distribute the electrical power that comes into multiple devices or PSUs out there. Then you've got a managed power distribution unit, a PDU, and that's a PDU with additional features like remote electrical power monitoring and configuration. So you can do remote monitoring and control it remotely in that sense and see what's going on. You've also got the most common one that you've heard of and may have in your own home is an uninterrupted or uninterruptible power supply, a UPS. That's a PDU that has a battery backup with it. Note that battery backup doesn't last that long. You don't want to be running your systems off of this. Usually a UPS is used just long enough to let you power down all your systems that are going so that you're not losing data and damaging anything. And then you've got a generator. A generator is a piece of equipment that's going to give you long-term electrical power during a utility power failure. So if you have the electric go out, it's going to be out for hours. Hospitals often have generators. They could be gas power generators that supply them with electricity for an extended period of time. We also have other things to be concerned about: heating, ventilation, and air conditioning, known as HVAC. That's the equipment that controls the environmental factors like temperature and humidity. That's very important inside data centers. We also have fire suppression. That's the fire detection and extinguishing or suppressing equipment that you have inside these places as well. So those are important to have. And that's pretty much it for this section on our redundancy. So let's take it back. We're looking at network redundancy and resilience, talking about, you want to have geographic dispersal. You want to have the separation of the server and other devices. We've got multiple paths. We're talking about redundant network devices. We want to protect our power supply. We want to make sure that we have diversity of technologies involved here. We talked about NIC teaming, NIC bonding, path diversity, path diversification. We talked about the different first hop redundancy protocols. And then we got into the power redundancy. We talked about the power supply units, the dual power supply units, the PDUs, the managed PDUs, the UPSs, the generators, the HVAC, and the fire suppression. So if you have any questions about this, feel free to contact me, and I'll see you in the next video. Aloha.